Доклад посвящен некоторым аспектам практическим попытки автоматизировать действия реверсера. Значит, кратко обо мне. Люблю язык ассемблер, сейчас уже в разных...
In different iterations, not only Intel, researcher, scientist was teaching at a certain period of time. Since 2001 till 2014, he was teaching reverse engineering, candidate of technical science, and right now working in an international team which reverses firmwares, dumps in inbuilt devices. Brief agenda. Intro, then we'll go some digging into the IDE and some ideas which really work. I will show you about two things to which I dedicated my presentation, and a plugin which is in the stage of development, in the final stage of development, transferring the reverse engineering results and some automated code analysis. Well, first I would like to tell you about two things. Due to the fact that I'm not teaching in the course of the last years, my lecturing skills are poor ones, so please don't think bad about me. And the second thing, because I'm involved in reverse engineering of various controllers, hardware, firmware. These are ideas which happened in the course of last year when I started working with this in great detail. So, previous works. First, I'm based on the previous year's work, which was a reverse engineering automation lectures and ideas which I had in the course of a long time since my thesis. And right now I realize them a little bit differently than before. So, what is the main difference between reverse engineering of firmwares from regular PC soft reverse engineering? There are certain peculiarities. Usually, binaries are of really small size, code is very simple. As a rule, no external operating system for such devices, for such hard things. Everything is inbuilt inside, working with equipment. No external calls or APIs and no operations. If you work with this hardware for the first time, the only thing that can help you is some signatures, IDA lib, and library signatures might help you. What is the other peculiarity? The compiler, except x86 and x64, also works for ARM. For other controllers, it's not operational. Practically, there are no emulators and debuggers. Emulators, which are existing ones, like Kale, in the emulation mode, they work pretty lamely with bugs. In JTAG mode, if you was able to connect the device and able to work with it, they also do not work very well. So in other words, when you look at all of these, you have the only way out. Sit down in statics inside of the IDE and just dig inside of all of it. As a rule, we're not going to speak about issues like how did we take this dump. We're not going to speak about any architectural problems, but we'll speak about it generally. Dump contains several things, usually. It's the main entry point when you hit reset handler, then interrupt vectors, in different areas, different controllers, they have them differently located. The one that I've been working with, it starts with a 0 address. Then we have a system bootloader, which prepares all of this. Then application bootloader, which boots the main application. Then main functionality application. There could be interrupt handlers, but some of them don't need it. And then some peripheral routines like CAM, BUS. I'm not going to give you any lists of this. Well, there's a lot of such lists in the internet. COM-port, UART, or some other things like that. Networking card. And right now there's a lot of devices, and device contains a lot of things. And of course there's also areas, random access memory areas in the peripherals, for which memory areas are responsible for which devices, basically speaking. And of course the problem that I have faced, that you spend a lot of time, your valuable time, you could walk around in the street, run and jump, but you see, do reverse engineering days and weeks. You have reversed it, you have looked at it, everything's wonderful, you have looked at the operating system, you see the work with FAT, what it does itself. You did it, you're cool. Yes, you're cool. But a little bit later, update was produced for this device firmware, and your results are in a previous DB file. What should be done with it? Manually, if you want to transfer it, well, it's not an option. You find yourself in a similar situation like this guy. What can I do with it? So let's try to generalize what are these RE results, reverse engineering results. I divided them into 4 parts in code. Names of functions, global and local labels, procedures, prototypes, and comments. And comments very often are some intermediate option in the data. Names of global and local variables, function arguments, variable types, and comments. Then meta info, structures and enumerations, structure members, which also can have comments, and also we have a certain structural info due to the fact that very often datasheet for some controller or for some device is not compatible with that address distribution and segments which are given to you by EDA. And you do it manually or with the help of some small scripts, you correct it. You correct the segments. Very often EDA does it in such a way so that functions, functions are improperly, incorrectly defined. You also have to correct all of these, and respectively, somehow you should look at the massives of variables, massives of structures. So this is our result. A regular way, when you have dump EDB file, you store it, type of information and database in EDC file, and then as a script you download it and you start it, execute it. But it has a number of problems. The first and the main one, it doesn't work on different dumps, because it is connected to certain addresses. And the second problem which exists, that even on the same dump binary file, it's not working correctly due to those things that we have discovered as a consequence of those structural differences. Something like that. Out of everything that is available, at least what I was able to see, what similar functionality can do. For example, there's a plugin, MyNav. It tries to take function and export them into a class functions matcher. See a functions matcher. It collects the this class and uses for it flowchart, and from the basic blocks collects a certain quantity of these objects. This its internal name, like in the script it's called, and these nodes are basic blocks. Then it has edges, which are links between basic blocks. Also, it has a concept called points. Once upon a time, I've been looking at what is the difference between this and this. Edges from points. Honestly speaking, I forgot this difference, but honestly speaking, it's a sum of all out and incoming links, outgoing and incoming links, and this is very close to the previous one. Previously, I knew it. Then there are instructions, just sum of all instructions inside of this function, inside of all basic blocks. So what we are able to do with it, it's oriented for x86, most likely, maybe x64, and an attempt to download it into ARM or other processor or controller has led us to the situation that scripts, Python scripts, just didn't start. So we came to the conclusion that it also dependent. And this was the main problem of many existing scripts. They all are oriented at certain tasks, and they are tuned up for controllers of a processor, specific ones. Usually for PC soft, less often for ARM, very often to search for script creators use just text representation of various instructions, variables, etc. Name of registries, they look at it as a text. And even more often, sometimes they use just initial bytes of instructions to search for certain patterns and come to certain conclusions. Example. We have function in the internet. It's a function from Prologues. It tries to find those functions that IDE didn't find. Therefore, let's look here. It just takes, and for Intel architecture, it looks for the byte which represents these two particular commands. It's not going to work on anything else but Intel. And here are the requirements. How we would like to see it. At the moment of work beginning, these are the requirements that we should have for this plugin. IDE Python, everything is very simple. In order for it to be independent from architecture and shouldn't have any connections to the architecture of processor and controller, well, there should be certain exceptions in the future, but these are things which can be tuned up. Then a certain information database, use simplest ways to get basic info and use simplest ways to extract new information. I've started this work approximately 1 year ago. Previously, I did a lot of reverse engineering, but usually I didn't do a lot of scripting. So this is some of my experience that I'm transferring to you of getting information by reverse engineering. So we will use the following DAMPs of the following controllers, and usually they are mostly related to cars, automotive industry. These are controllers. First three are parts of engine control unit of different vehicles. And you can find all these firmwares in the internet. You can download them and look at them. So we need to do the first thing. We need to get some basic information. The simplest one, and everybody knows about it, if you have done scripting ever in your life, first you need to get X references. cross-references. And you will see some simplified examples in my presentation. For the sake of presentation, of course, it was done. So this is a code which is given to two different commands, two different addresses, two references. Ordinary flow, it's an ordinary execution. Data read, data write means that def we record, and in 4b we write. Everything's very simple. So the next one references to certain tag. You can see a little bit more here. If in the previous one you could see code references and references to data, in this one you can see only mostly code references. You can see that from the previous command we see a regular execution and 5 jumps. It's an auxiliary mechanism of cross-referencing. Next one. Also we have local variables. And here's a script which shows the name of a variable. Sorry, not the local variables, but local labels. And there's a script which posts these local labels, their names. And in this one, you can see the situation. We have not renamed this local label in address 22.2. And 288, we have also looked at it. We have looked at what leaves it and what comes there. Sorry, what comes there. There's a jump here and jump here. So there are two different outputs from procedure. Through some conditions, practically they do the same thing. Then, if we label this label as an exit, then this name is disappearing from here. It's a peculiarity that disassembler from IDE has, that automatically named labels, they are global. So if you have renamed it, it becomes local. Then you look at other options and you don't see it here. There's a solution here. Just use another function, name EX. You can look at regular name, you can look at name EX. With the name EX, it shows it this way. So you have two mechanisms available. You need to collect global labels and local ones as well. Segment related information. Segments is a very simple object which contains data codes, and I have noticed and I had certain experience that in the best case to describe the areas of memory responsible for peripheral devices is to create certain segments for it. For example, IDE has created it automatically, but generally speaking, you can also do it manually as well. You can look at descriptions of this device and you can create all references, and they will start referring to normal variables. So in the given case, it's very simple. There's a get segment attribute procedure, and I'm setting different flags, and we get different segment properties. Beginning, end, name, param, base, access rights, bits, flags, types. Next thing that you have to pay attention to is structure members, meta information. This is a structure. I'm not going to discuss everything, but in the top of these examples you see controllers are different on top of the examples. In order to show you that, It works for everything, and even for x86 as well. So the next one, structural elements. You can also receive through these APIs various attributes. It's shift, and this is the main property for it, size, flags, these element member structure equals -1 bad address. But if this element will refer to another structure, then you will see ID of this particular structure here. And this is a really common mechanism for ARM processors. It's when it starts during loading, it starts copying certain areas of memory, and for this particular purpose, this structure was done. Therefore, from the element of structure, you can go to the structure itself. You can list what contains in this structure, its attributes, its identifier, name, then also size and quantity of those elements, names of those elements. In the script here, you can see how you can discover all of this. And right now I'd like to say a few words, and let's dig even deeper into the IDE. Global variables. Global variables, they have common attributes, which also can be acquired by these IDE API functions with get flags, get tag, and name. And of course, we get flags. It's the main thing here. If you look at type, then it's basically a prototype. It has not been defined yet. Then you'll be able to learn some additional properties of those flags. You can get it through the base elements like ham. Many of you have worked with it already. It was, well, a separate script was described for researching this head. It parses it and shows all its information which is available. For example, up here on this FFEC address, we have a variable which has 2 byte size word, and we see a reference to it. Everything is recorded in this head element, in this particular flag, in this particular byte. In this big integer. So it's a data byte, has references, it has domain name, it's a name by default, then word and 2 bytes variable size, and then in head it stores the value of the first byte, 3FL. So here's an option of the output when it refers to the structure. Down here you see a separate flag showing that this is a structure. Up here it's a structure that we've been looking at before, and down here it has a name, has user defined name. So in other words, we can take all this information. So domain name is not a result of reverse engineering, and we shouldn't transfer it. We need to take only user defined one. Next one, this head element also allows us to work with commands. It describes them actually, but I've noticed that in a strange way it is being done. For example, we have a command which has only one argument, and we transfer href from this command, and we see that it writes data write. So it should output, it should print in flags, and information should show the information that argument refers to data. But it didn't happen. Where is it? Nobody knows. But let's look and try to check another controller, Siemens 166. Same thing. We have record, a certain word of a certain number. We have data right, reference, cross-reference from it, but we see no information about argument. Let's look one more. So we already have 3. Let's look at 3 out of 4 that we have available. In this one we have the similar situation, but the only difference here is that we have reading, not writing. 57A address, so it's reading from this particular byte. And it happened, well, it was a very interesting situation that in head element, IDA stores, out of everything that we're able to see, it stores information about arguments. Here's that argument type for this particular line, 290H. Storing R3 registry. So it stores only for 864, 86 and ARM processor. For other controllers, this information in head element is not being stored. It's kind of internal peculiarity. So for the head, we cannot rely upon head for these particular situations. Next thing that I would like to speak about, and we have to transfer it, it's a function. It has a certain common attributes, script which shows them, start and function flags type. You can get frame stack for it, and in a given case, if in any case it doesn't exist, then you will not see it in the output. So in a given case it doesn't exist for this particular function. Let's look at variant for the ARM processor. Sleep function with a name, and it has a prototype. Timeout argument in a type, you can see it here, and stack frame exists for it. Stack frame, we need it for getting local variables. Then we are trying, what kind of identifier is it? Identifier of stack frame is an identifier of structure that we've been looking at previously. Where was it, this structure? Well, here's a structure. Let's take this particular script. You don't see it to the end. And then we're trying to print our frame. We start it and goes to the everlasting cycle, because down here there's a situation to the infinite loop. Well, the stack is available, but it's 0. It's also a common situation, this infinite loop. Well, my speech capabilities are deteriorating already. Well, therefore, by starting listing, this script goes into the infinite loop. But after correcting it a little bit, if the number of members of this particular structure will not be equal to 0, then we'll print it. So it's a very simple code which prints everything. If you start listing elements of regular structure, it's not so obvious, but on frames, on stack frames, you can see it immediately, especially when you start listing elements. In addition to the fact that it posts everything that we already have notified, it also starts everything that is being defined, showing us by byte by byte. It's not the best, it's not the worst option, but you have to get rid of it. You should correct a little bit, and then we have an output of the following information. We can get the name of the structure, the name of stack frame. Usually it is similar to the initial address of this procedure, and then you get elements which are defined, which are not undefined. And here's an example here. It's a very obvious one. All the APIs are used. In addition to listing stack frame through the structure, there's another option of and a set of APIs to get various parameters of this stack frame. These APIs are not connected to stack frame as such, but to the function itself. So this is output of various parameters. And well, it seems like a good option. We have local parameters, their size, the size of stored registries, and the size of transferred arguments. But down here we can see that we have a certain argument. We have registries, and you can also say stored ones. But as an option, it's just memory allocation for local variables, but most likely these are stored ones. And here's an argument. But results of this print, of this output of this script, shows us that local variables, 24 bytes given for them, and for stored registries and argument, zeros. Why? And of course, we can use two other ways to get the size of this stack frame. Through the structure, through the size of the structure, and through the size of the frame. Through the size of the structure, we have received 28. Through the size of the frame, 24. What is the difference? Well, we have figured out that frame, this particular frame, in some way dependent on processor, at least a little bit. And being more particular, these two fields are these two APIs. So frame takes in consideration only local elements. In a structure, we can take in consideration the second one. So that's why the difference is 4 bytes. After looking at ARM, we also acquire interesting situation here. Can you see it here? Can you read it? Letters are very small on the screen. Can't you read it? No? Only the header, but the content is not really obvious. Oh my. For some reason I thought that you'll be able to see it. Well, in other words, I will tell you what happens here in more detail. Then we get an interesting situation here, that local variables, we have 8 bytes allocated for them, the size of the frame 8, structural size 0, some misalignment. And then I've noticed that these two APIs, the size of stored registries and the size of arguments, are connected to Intel platform. The size of the arguments shows the number which is returned together with read, the size of the received byte, and registry size is something that is being used for the work with a stack frame through the EPP registry, so you cannot rely upon them as well. So transferring of reverse engineering results, the main ideas, the main things. For the base, we took a function, and with the help of this object that was realized internally, we collect maximum information available about composition of this function. Compared to MyNav, while graph of internal function controls have not been used, only those mechanisms that I've been showing you. And of course, by using this different information in a new dump, you can search for similar functions similar to our function. The second option is to use values of variables and cross-references between code and data to recognize variables inside of this new updated binary. Through these variables, we can get access to functions. And we can have, if in a basic dump, which you have researched, the function has been returning to 3 variables and has been recording them. 3 variables were read, all three of them were red, but by discovering in a new dump or trying to find variables with similar names, with similar values, and by finding a function which refers to them for reading 3 times, well, with a certain level of probability, you can assume that this is the same function, and respectively, iteratively, you can do these 2 things, you can get new information, of course. Which information you can get from it? These scripts, you cannot read the content, right? Sorry. Well, I'll give you the presentation, you'll read it later. I thought that it's going to be seen on the screen. So script here gives the number of commands. The same parameter was used in my nav plugin. So we go through all the heads inside of these functions and we try to see the number of commands. And then we get a strange situation. We have a function, it's 1 command. Then we go in the beginning of it.
Он пробегается по всем head, используя 2
Well, it
параметра.
goes through all the
Это
heads using 2
func start
parameters.
и func
Func start
end.
and
То есть
func
начало и
end.
конец функции
Beginning and the end of
получено
the
вот
function
такой процедурой, как getFunc
received
attribute.
from the getFunc attribute.
Значит, идя в начало, и
Going to
видим,
the
что вот
beginning,
одна эта
we see
команда.
that this
То
particular
есть
command,
такой простой, казалось бы, способ
and it's a
прямой,
simple way, direct way,
не помогает, вернее,
it still
не
doesn't
работает
help us,
абсолютно,
and
когда у
it
функции
doesn't
есть
work
чанки.
when the function has chunks.
Чанки
Chunks
достаточно частое явление.
are
Ну
thing
и
that we see
как
very
бы
often.
было просмотрено несколько способов,
So we have
как с
looked at
чанками
several
работать.
ways on how
То
to
есть
work with
через,
those chunks.
ну вот то, что было уже, это
what was
через heads перечисление,
Available through heads,
потом через такое понятие,
then
как
to the
chunks,
concept
и
like
через
chunks,
items,
and
через
through
func
items. Func
Ну и,
items.
соответственно, вот есть та же
Therefore, we
процедура.
have the same procedure.
Снова с heads получаем,
Also with
что
heads,
одна команда
we
всего.
understand that only one command
Вот,
is available here.
через чанки получаем,
Through
что 24
chunks,
команды,
we
через items
get that
получаем тоже
24
24.
commands, and through items
Ну и через
also
чанки еще
24.
выводит состав
And
самих чанков.
Chunky also
Вот,
has the composition of chunks
чем еще
themselves.
чанки от
What
items
others,
отличается,
what other difference
можно
between
увидеть вот
chunks?
здесь.
You can see it
Значит,
here.
бывает часто ситуации,
Very
когда,
often we have a situation when
ну, для ARM типичная
for the
такая ситуация, когда он располагает данные
situation is
внутри
very typical
функции.
when it
Соответственно,
places
да,
data inside of the function.
по-простому
Then
делает,
yes, it
то
does
есть
it
если
very
данные,
simply.
ну, для
So if
адресации
the data
в
for
этом
addressing
режиме,
in this particular mode, forgot.
то есть для адресации в
If you
режиме,
want to
когда
do addressing in a mode when
из головы вылетел. Как называется? В армии
forgot.
режим. Да, для тумб, в режиме тумб, спасибо. Вот,
In a
используется,
dump mode.
ну, такая ситуация, что
We can
данные
use a
располагаются
situation
прямо
that
внутри
data is
функции
located inside
и
of the function,
перепрыгивается в
and
безусловным
then
переходом.
it jumps by.
Соответственно, если мы будем
transition.
подход
So
использовать
if you will
через
use approach
чанки и
to
перечисление хедов,
chunks and listing heads,
которые находятся в чанке,
which are
то
located in the chunk,
эти
then
все данные она
all this
воспримет
data
как
will be
ну,
perceived
количество
by
там,
it
команд.
as a quantity of
Поэтому
commands.
самый такой
Therefore,
нормальный вариант для
The
перечисления
best
именно команд,
option to list
получения
commands
количества и
and getting
ну,
quantity
корректного их перечисления,
and
это просто
their correct
использование
list is
items.
just to use
То есть он
items.
показывает верное количество
It shows you the
элементов.
proper number of elements.
Ну и как бы есть вариант
And
вот скрипта,
there is an
который
option
получает
of a
все
script
чанки
which
вообще,
gets
которые
all the
есть в
chunks
модуле.
which are available in the module.
Но вы его тоже не видите.
But you also don't see
содержимого.
it. You don't see its content as
Вот.
well.
Ну, он очень интересен
But
тем,
it's very
что,
interesting by the fact that,
допустим, на
let's say,
файлах чуть большего размера
in a bigger
он
size
приводит к тому,
files,
что еда
it leads
валится
us
на
to
нем.
the situation that IDA just
Почему, пока не
fails.
выяснили.
Why?
Ну, то есть,
I have not
вот
figured it
этот
out.
дамп 50,
But
ну,
this
500
dump
килобайт был. Ну,
was
изначально.
500 kilobytes. It was the total size
На
of this
там
dump.
6-мегабайтном
On 6
экзешнике
megabyte
интеловском он
exe
там тоже
from
валится.
Intel, it also
Просто
fails.
перечисляет все чанки.
So
Почему,
it
не знаю,
just
надо
lists
им
all the
будет
chunks.
написать,
We'll
поддерживать.
have to write to
Значит,
the
он,
support office.
на самом деле, функция
But honestly speaking, this
внутри,
function
ну, как бы,
inside
как таковая, она тоже воспринимается
is
как
also
чанк.
perceived
То есть
as
любая
chunk.
функция — это и есть чанк.
So
уже.
any function is a chunk,
Неважно,
irrespectively
и функция
to
может состоять из нескольких
whether
чанков.
function can consist of several
Есть такой
chunks.
момент. То есть он все функции, по сути,
So all
перечисляет
these functions are
перечислением
being
этих же чанков.
listed by listing all these chunks.
Ну, поиск по под процедур вызовов. Тоже
Then
достаточно
subcall
хороший вариант.
finding, it's also a good option.
Как правило, при
Usually,
обновлении ПО
while updating the
не
software,
может все там меняться.
it's impossible to
Как
change
правило,
everything
какие-то
as a
базовые
rule.
процедуры,
Certain basic
там, работа с
procedures,
периферией,
the
они не
work with
меняются.
peripherals, they
Меняются
are not
какие-то
changing.
высокоуровневые
Maybe some
вещи.
high-level things are
Если
changing.
высокоуровневая
If
функция будет
high-level
вызывать одни и
functions
те же
will call the
функции,
same functions
что и высокоуровневые функции,
as
исследованные
high-level
вами,
functions researched by
какие-то
you,
базовые.
some
Соответственно,
basic
это она и
things.
есть.
So
Ну, с
that's
некоторыми,
it.
может быть,
Maybe
внутренними
with
изменениями.
some internal changes.
Получаем вот все
So
вызовы.
we get
и
all the
перечисляем.
calls and list them.
Ну, вариант поиска
The
всех
option
как
of
бы,
searching
переменных,
for
на
all the
которые ссылается
variables
адрес
to
и
which the address is
переменной.
referring and address of this variable itself.
предварительный анализ.
Well,
В чем
primary
состоял?
code analysis. What was
Значит,
all about?
первое это поправить
The first one is
некоторые
to correct
неточности
certain
дизассемблера.
imprecisions made by
Найти те
disassembler
функции, которые он не
and find
определил.
those functions which it has not
А,
detected.
Диапазон функций
The
несколько
function range should be detected.
поменять.
We should
под
change it for
правильный.
proper one.
Создать сегменты по
Then we should
периферийной
create
этой
segments for
области,
these peripheral areas.
найти
We
entry
should
points,
find all the
то
entry
есть там
points,
reset handler, какие-то еще
set
обработчики.
handler, some other
Ну и из простого,
runners,
то
and
есть
from the simple ones,
просто простых каких-то
just
меток именования,
simple
думаю,
local
будет полезно,
label
чтобы вы не
namings.
смотрели, что это
And
там
this will be
лог
good for
с
you,
каким-то
but your
номером, а метка
can
и
see
exit внутри
know,
процедуры уже будет полезнее.
exit inside
И
of the procedure,
простых
then it's
каких-то
going to be better,
процедур
and some
именования.
simple procedures.
Также поиск
Also, search
отдельно висящих процедур,
for
которые никогда не
separate
получают
procedures
управление.
which never get
Может быть,
control,
в исходниках как бы
maybe in the
остались,
source code
но их
they have
оставили,
been
можно посмотреть,
stayed,
что там.
and you can look inside of them and see
Значит,
what's there.
ну вот вариант как бы
There's an option.
по каким критериям
Which
допустим,
criteria you can use
вот
for
эта меточка, которая сама на себя
this
прыгает.
label which jumps upon itself.
Тут достаточно все просто.
Everything's very simple
Обычно
in this
xref
case. Usually
берем
xref2
И
is
смотрим,
taken,
что
and then
как бы
you
она
can
сама на
look
себя
at
прыгает.
the fact that it jumps
Отдельно
upon
можем
itself.
выделять это
And
как
you
процедура,
can,
это очень
separately
ну,
separate as a
удобнее, чем
procedure.
просто как
It's
какую-то
much
метку.
better than a
И
simple label.
именуем
And
как
then
бы
you get
процедуру,
around
выполняющую бесконечный
the
цикл.
procedure which
Как бы
does
вручную, конечно,
for
можно
the
все это делать, но
internal
их там
cycle. Yes,
может
it can done
штук 300
manually,
быть.
but you
как бы
should
руки
have
устают.
300 hands in order to
Вот.
stop this
Значит,
too.
ну еще вариант, когда
And
вот
another option is when
функция может несколько точек входа в себя
functions should
иметь.
have several entry
То есть
points
вот
into
здесь,
itself.
допустим, вот на
For example,
начало вот этой как
in
бы
the beginning
функции
of this particular function,
смотрим, какие
you
xref
can look
к ней
at which
ведут,
xrefs
и
are
смотрим,
leading to it, and then
что
you can see
помимо
that
прыжков
in
на
addition
нее
to these jumps to it,
идет еще
you can
ordinary
also
flow с
see
предыдущей
ordinary
команды.
flow
Все
from
это как бы
previous
процедура,
command.
у
So
которой на
this is a
самом деле два
procedure
входа.
which has two
Тоже
entries.
не частое явление.
It's not
То есть
something that
количество
happens too
входов
often. The number of
используется,
entries
и
can be
количество
used and the
выходов.
number of
Его
exits
тоже можно
as well.
находить и
You can also
использовать
find it and
для
use it for
переноса разработки.
transferring
Поэтому, ну, как бы
development.
предварительно
Well, this
такие
is
ситуации надо
previous,
обрабатывать.
and these situations
Что
should be
следующее?
processed.
Значит,
Well, what's the
что
next?
дальше с этим
What's
всем
next?
делаться?
Should be done with all of
Будет.
it.
Ну, имя надо придумать.
We should define a
Вот.
name.
Несколько идей еще есть,
I
которые
have several
надо до
ideas
конца
that I should
протестировать.
complete. We should test it.
GUI добавить, потому что
We should
пока в
add
таком
graphic user
командной
interface.
строке
In
работает,
this command article,
может быть,
it works
на
to make
контест
the
плагинов отправить.
we should send
Ну и
it to the
опубликовать.
plugin contest, and then we should publish this plugin.
Спасибо,
Thank you
очень
very
прошу
much.
прощения за
My
то,
apologies
что вы не видели
for
особо, кроме заголовка,
small
что здесь
letters on the
происходит.
screen because you were not able to see what happens on the
Почему-то
screen.
у
For some
меня было
reason,
мнение, что экран
I had an
будет
opinion
так вот,
that screen was like that,
и вы все будете
and you will be
прекрасно
able to
видеть.
see everything.
Спасибо,
Thank you very
вопросы?
much. Questions?